So in this lesson, we're going to take a word problem and translate it into an inequality, and we're going to put it in standard form. So just a reminder, standard form would be when the x's and the y's are on the same side. Okay, when we talk about linear equations, here we're going to talk about linear inequalities. So let's go ahead and read the problem. Starting up here with Boondin. Boondin decided to sell some learns. Learns are going to be the x's, and the pisquets are the y's. So learns and pisquets, he's selling them. Altogether, he planned to sell at least 5 items. So at least 5, at least means he doesn't want to be less than 5. He wants to be equal to 5 or greater. So he has a bunch of x's, and he has a bunch of, which are the learns. He has a bunch of y's, which are the pisquets, and he's going to sell. He wants to sell at least, so we're adding them together. He wants to sell at least 5 of them. So it could be greater than or equal to 5. So my plan now is to type this in the box as the inequality. So let me pause and do that. Okay, so what I did was, if you look over here, I used the menu button down here for the greater than or equal to, and I put it up here, if I could show you without moving everything, put it up here. So let's see how we did. Let's tap the button, and that is correct. Now the second part is we have to give, in this case, one impossible pair of numbers. So in other words, an x and a y, a bunch of learns and pisquets that would not work. Sometimes it'll ask you which are possible. This says impossible. In other words, write a point using whole numbers only. So we're going to grab our parentheses. So how many of each would not give you greater than or equal to 5? Well, you could sell 1 of one and 3 of another. It could be 0 and 4, 0 and 3. So I'll put 1 and a comma and a 3 because it's an ordered pair. And we'll see if we got it correct. Many different ways you could have done that. So I'll clear off last problem's work. Let's look at the next one. So this one's about Frank. Frank decided to purchase some Boondins. There's X of those, and tots, there's Y. Tots cost $2 each. Boondins cost $2 each. She could spend at most $14. Write an inequality in standard form showing the above constraint. Constraints are, whoops, I must have tapped something. So a constraint is a rule you got to follow, or just limits you got to follow. So let's read it again and do some highlighting. Frank decided to purchase some Boondins. So the Boondins are the X and the tots are the Y's. You could change colors if you want. I'll circle the Boondins, the X's. The tots, which are the Y's, cost $2 each, so I'll underline that. And the Boondins cost $2 each. That kind of makes it easier because each are $2. And she could spend at most, so I'm going to change my color for this, at most $14. So she must have like $14 in her pocket. She can't spend more than that, but she could spend less than or equal to. So let's think about this. Boondins are X's. They're $2 each. So $2 for every Boondin. And the tots are also $2 each. So that's $2 for every one of those. And if you add them together, she can spend up to 14. So less than or equal to 14. That's the most you can spend. So I'm going to tap this over here. Lights, camera, action. Let's see what we got. So that's correct. The next part that says choose the false statement. Again, sometimes they'll say choose a true statement. So I circled the Boondin. Boondins are the X's. So it says the first choice is 4 Boondins and 3 tots. So the Boondins are the X's. The tots are the Y's. Just keep that in mind. So let's substitute in 4 for the X 2 times 4 is 8. And 3 would be the y's. 2 times 3 is 6. 8 plus 6 is 14. Less than, no, but it can be equal to. So that one would work. We don't want that. We want a false statement. So now we substitute in 4 for the x. That's still 8. 2 for the y's. That'd be 8 plus 4 is 12. And 12 is less. So that one would be true also. So let's go down and see the third or fourth one. So you buy 1 Boondin. So you put 1 in for the x. That would give you a 2. Then you put 7 in for the tots. 7 would be the y. 7 times 2 is 14. And we add those together, you get 16. 16 is not less than. So that's the one we're probably going to go with. But I always double check the last choice or the other choices. 2 times x is 4. 4 times y, or 2 times 4, which is the tots of the y's, are 8. That would be less than 14. So it's got to be this one here. It's the only one that is false, although other ones would make the inequality true. Got it. All right, let's try another one. Aliber decided to sell some vreels. Vreels are the x's, and jugs, which are the y's. The vreels, which are the x's, are $2 each, and the jugs, which are the y variable, cost $4 each. She needs to make no less, so she wants to make some money here, and she doesn't want to make less. She wants to make either equal to or more than $16. So write an inequality, again in standard form, ax plus by, showing the above constraint. So I'm thinking to myself, x's, the vreels. Vreels cost $2 each, so that's 2x. The jugs are $4 each, so that's 4y. And we want to know how much she's making. That's how much she makes for each of those. So together, she doesn't want to make less. No less. She wants to make more or equal to $16. So I'll type that in. Okay, so I typed it in. It worked. Now in the next statement, it has a bunch of ordered pairs. Which pair of numbers is not in this relationship? So we're looking for ones that don't work. So again, substituted x's and y's. So if I put in 6 for x, that would be 12. If I put in a 2 for y, that would be 8. Add them together, you get 20. 20 is greater than 16. So that would work. I'm looking for one that doesn't work. So let's go to the next one. 2 and a 4. If I put 2 in for x, I get 4. 4 and for y, I get 16. Add them up, you get greater than 16. So 0 and 2. If I put a 0 in for x, I get 0. A 2 in for y, I get 8. Add them together, it's not greater than 16, not equal to 16. So that looks like a one-on-one. If I use 0, 4, I get a 0 for x times 2 is 0. 4 for y, 4 times 4 is 16. That would make it equal. So the only one that is not in relationship would be this one here. So again, I just caution us, at times they're going to say which one is a relationship. This is, again, which one is not. It's almost like makes it false. Okay. Last one. Let's take a look at it. Decided to purchase some doubles, which are the x's, and quecks, which are the y's. Doubles I'm circling cost $4 each, and the quecks also cost $4 each. She could spend no more than $12, so not more than 12. So it could be equal to or less than. So the inequality, the doubles, the x's, are $4 each, so that'd be 4x. And cost of $4 each for the quecks, that's 4y. And not more, so it could be less than or equal to 12. We'll type that in. And then what's going to happen is we're looking for a possible pair of numbers that make that true. So think about that as I type this in. So now I'm looking just for one possible pair of numbers that makes that true. So if they sell 0 or purchases, right? Buys 0 of the doubles, but 4 of the quecks, that would give you 0 plus 16, that's too much. So 0, 4 wouldn't work. But 0 of these and 2 of these, that would give you 0 and 8, that would be less than 12. So I can use 0, 2. So I'll type in 0, 2 as an ordered pair. And again, there's so many others that would work too. So just make sure you got one that works this time. Let's check it out. All right, good luck with those. Do your best.